where we look at smart contracts with the people who wrote them. I'm your host Shafu, and today's episode is a special episode because I'm hosting myself. I want to present the DYAD contracts that we wrote the last couple of months or so. We just finished our first solo audit, so I think um, there will not be any major changes yet. Just as a side note, we already launched the NFT contract before, and this is the second part of contracts that we're going to launch, which will include the first vault manager and the first vault. And after that, we're gonna launch some very interesting stuff on top of that. So what I want to go through now is the NFT contract, the vault manager, and the vaults. So just from a high level point of view, how DYAD works, we have this NFT ownership system. So we call them DNFTs for DYAD NFTs, and each each DNFT gives you the allows you to mint DYAD, which is our stablecoin. So basically, you can think about every DNFT as its own central bank. I know central bank is not a term that crypto people like, including me, but uh, I think it's a good metaphor here. Okay, so that's the repository. It's the V6 one. We rewrote these contracts a couple of times, so this is V6, and I think the one that we're gonna launch with. Okay, so jumping into the code, the first thing I wanna go through is the DNFT contract, which is a basic ERC 721 contract. Nothing really fancy here. We can keep track of public mints, insider mints. We have some DNFT allocation for the team, investors, and so on. Nothing really fancy here. Uh, what we have this linear price increase. So after every mint, the next DNFT gets a bit more expensive. Um, but other than that, we also have the mint insider NFT that only our multisig can call, and drain function to get the ETH that people paid with for the DNFTs. Okay, so as I've said, the DNFT is the core building block of the system. Everything goes through the DNFT. If you want to mint DYAD, if you want to burn it, you have to go through your DNFT. If you want to put in collateral, if you want to remove collateral, you have to go through the DNFT as well. All right. Then let's switch to maybe let's start with DYAD itself. DYAD is the stablecoin, ERC20. What we have in here is we have a mapping between, maybe this is a bit interesting. The vault manager, and then a mapping from DNFT ID to DYAD. So we keep track of how much DYAD did one DNFT mint or burn. But we also keep track of the specific vault manager. And we did that so we have a lot of flexibility to deploy new vault managers if we want so, which is the plan in the future. So for example, we're thinking about a design where you don't have an oracle, for example. If we want to deploy that, we need a new vault manager. And so everything in here, the mint and the burn, has to go through a vault manager. It needs to be licensed as well. What this licensing is about is we have this licenser, which right now you can add and remove something into a mapping from an address to a boolean. This will be controlled by a multisig to start with, but we will decentralize this over time. We still didn't figure out the correct a great way to do this. We have some ideas, but for now, simple multisig behind it, which can add new vault managers and new vaults. Okay, let's take a look at the vault manager. So how DYAD works is it's multi-collateral. So each vault manager can have multiple vaults, and these multiple vaults are managed by the vault manager. Um, and yeah, and every EUA interaction will be through the vault manager. You will never directly call something inside the vault. Everything goes through the vault manager, which I think is the better abstraction. I know it has some gas overhead, so theoretically you could do everything inside the vault manager if you use the same oracle. If you don't use the same oracle, you would still need to deploy a new contract. But still, you could do a lot more inside the vault manager. But we decided against that because I think that's the better abstraction here. So yeah, let's start looking at the vault manager implementation. So we have the max number of vaults that one vault manager can handle. We have this because you have a for loop to iterate over all vaults, and obviously that's a DDoS attack if it's too big. So we limited that to 5. I actually need to do some gas experiments. I think it can be higher than that, but for right now it's 5. We also have a minimum collateralization ratio of 150%. If your DNFT position or the whole of your collateral, all your collateral types inside your position, if the aggregate gets below 150%, someone can come in and liquidate you. And we have a liquidation reward. Okay. Which is 80% for now. I think that's way too high. Actually, I think that's gonna be something like 20% actually. But yeah, the parameters are still things that we're gonna play with. This is not fixed yet. We'll definitely do some simulations or something to see what fits, what's the best fit. Okay, then of course immutable reference to the DNFT, to the DYAD, and the vault licenser. Your vault has to be licensed through the licenser in order to be added to your DNFT position of vaults. And as I've said, the licensor right now just a multisig, but will definitely be decentralized. Okay, how we keep track of the vault is just a mapping from a DNFT ID to a enumerable set of type address. Actually, before the solo audit, I basically re-implemented the OpenZeppelin implementation of this without knowing that this exists. So this was a really good refactor. Other than that, we have some modifier. Is the NFT owner? Are you the DNFT owner? Is it a valid DNFT? So does the DNFT actually exist? And is the vault licensed? Okay, the constructor trivial. Okay, and the first functions that we have is add and remove. So add is a function that you can add a vault to your vaults positions, and remove obviously is the opposite. You can remove a vault from your position if you want to. So add a couple of checks that you have to do. Did you already pass the maximum number of vaults? Is the vault licensed or not? Did the addition fail? And this is the great thing about the OpenZeppelin implementation. You don't have to. It's a set, so If the address already exists, this will fail. Um, and remove. We actually need to check that you don't have any more collateral inside the vault that you want to remove, because otherwise you could do some weird stuff, and basically avoid liquidation if you play it correctly, which we don't want. So we have to check, does your vault have any collateral in it? If yes, you cannot remove it. Other than that, we check did the removal succeed or not. If it doesn't succeed, we revert. Okay, so that's additional removal. Then we have the deposit and withdraw function. Um, so the deposit function takes in again the DNFT ID, the vault that you want to deposit into, um, and the amount that you want to deposit. Um, so actually, maybe one interesting thing here is, um, we don't check if your vault is inside your vault positions, and that's actually an interesting philosophical smart contract engineering point of view. So my point of view on this is I don't check for user error in smart contracts generally. So if you deposit something uh, inside a vault that isn't in your position or something, um, then you can do that, but you will not gain any benefit from it. Um, and there it isn't exploitable, so I think it's totally fine. And yeah, so inside the deposit function, we transfer the collateral from your address to the vault, and then we call the vault deposit function, and um, withdraw calls into the vault withdraw function, and then checks. It has to check if your collateralization ratio is still larger than the minimum collateralization ratio of 150% right now. So actually, let's take a look at the vault, because we're calling into the vault. So inside the vault, um, and yeah, I know when you say vault, you directly think of an 4.6.2.6 vault, which isn't the case here. Maybe bad naming. We probably need another name for that to avoid confusion. But for now, we called it vault. So we have a mapping from ID to asset. So we keep track of the DNFT ID to how much collateral you have. Then we have a modifier to check if it's the vault manager, because as I've said before, you cannot interact with the vault directly. You have to go through the vault manager. And what we have in here is deposit and withdraw, and we just increment ID to asset here, and decrement it here, and transfer it to yourself once you call withdraw. We also have a move function that moves collateral from one DNFT to another. Um, this is something we use for the liquidation mechanism. So how you liquidate is, actually we'll wait for that and look into it once we're there at the in the vault manager, which should be next. We also have get USD value, which calculates your current USD denominated value of the collateral inside your vault. And we have asset price, which calls into the oracle and gets the price for that asset. So that's for the vault. Then inside the vault manager, did I change? Oh, I changed that. Okay. Okay, so we have the DYAD function, which you would call to mint new DYAD. It calls into the ERC20. And as you can, if you remember, only the vault manager can call the mint function. We call that, and then we check, are we still higher than the required collateralization ratio. Um, the same for burn dyad, but we don't need to check the collateralization ratio because burning dyad will only increase your collateralization ratio. Then we have redeem dyad. So in redeem dyad, as parameters, you have to set the DNFT ID. You have to define which vault you want to go through, and the amount you want to redeem and the address that gets it. What we'll definitely build around that is a way to move through several vaults um, in one transaction, which I think is a good abstraction for the end user. So just imagine you have like 3 vaults, and and you want to redeem your dyad against all 3 vaults in some specific quantity or something. Um, then you should be able to do that. We'll still need to build something around that. Okay. Um, so the liquidation mechanism. So the liquidation mechanism, again, 2 parameters: the DNFT ID, and so the DNFT ID that you want to liquidate, and 2 is the DNFT ID that gets the collateral as a liquidation reward. Um, so we check the collateralization ratio. We check is it lower than the minimum required collateralization ratio or not. If not, you cannot liquidate. If it is lower, then you can. Um, then you have to give it the dyad necessary um, to pay off the debt. And then we basically calculate your reward, and we loop over every vault, and vault moves the actual collateral from one DNFT to the other. Okay. So again, a for loop here. That's why we have the maximum number of vaults. I know I always cringe when I see a for loop in a smart contracts, but there is basically no other way to do it. So we need that for loop. Okay. Other than that, some helper functions to get the collateralization ratio, and get total USD value basically calculates the USD denominated value of all your vaults. Again, for loop over all your vaults. Then one simple function to get vaults, which just returns the vaults for that specific DNFT ID, because um, because vaults is internal. It has to be internal because it uses the Open Zeppelin Anywhere set. It cannot be external or public. Okay, so that's that's basically the vault manager and the vault. As I've said, the DNFT contract is already deployed. You can mint one if you like. The vault manager and the vault we're gonna deploy next. Maybe one last thing we can look at is the some deployment scripts that we have. So I know this can be optimized and done in one transaction, but for now, it deploys 2 licensors, one licenser for the vault manager and one licenser for the vault. It deploys the DYAD contract, the vault manager, a vault. The first vault will be some type of ETH, so staked ETH, wrapped ETH, something like that. Then we add the vault manager to the vault licenser, and we transfer the ownership of the licensors to some multisig that we have. All right. So that's DYAD. Um, if you want to find out more, everything is is in here on our GitHub. We strongly believe in building in public, so everything we do is open source. Um, and yeah, you can reach us. I think the best place to reach us is probably, let me move this, probably Twitter. So I'm gonna link our Discord in the description below. And if you want to reach out to myself, Twitter is probably the best place. All right, then thank you guys. A little bit different this time, but I'm really excited about the DIE contracts, so I thought I would do this episode. So yeah, thanks for tuning in, and see you in the next one. Bye bye.